with you because we get so excited about that rule that says if log A of x equals log A of y, then x equals y, right? We have that. Log A of x equals log A of y if and only if x equals y. So people know that, but then they see something like this and they're like, I'm just going to get rid of all the logarithms, which is not okay, right? You can only do that if you have one log equal to one log. So my question is, can we make this into one logarithm? Because we have a property, what does it mean when we're adding two logs? What can we write that as? Multiplication. So if you don't do that first step, then you're going to get the wrong answer. And yes, you can go ahead and distribute that if you want. But if you just get that first step where you can write that as one log equals one log, then you can do the property over here. Then we can say if log 2 of this equals log 2 of this, then yes, this has to equal this. So yet another thing that's not so bad to do, but you have to recognize what am I allowed to do, what are the properties, what are my rules for doing this. So I'm going to say that's the same as x squared plus 2x equals x plus 6. And then what do I have to do to solve that? What kind of equation did we just make here? A quadratic. We never escaped quadratics in that class. If I subtract x over, I would get plus x minus 6 equals 0. Okay? We can complete the square, we can do the quadratic formula, we could factor, can we factor that? Three times 2 equals 6. Positive 3, negative 2. Does that work? Sometimes they're not factorable, which means you have to do the quadratic formula or complete the square. We've been doing that since, I think, chapter P. We talked about completing the square again. So hopefully we're feeling pretty good about solving quadratic equations. But we have to be really careful when we get our answers here, because what can't you take the log of? You can't take the log of a negative number. You can't take the log of 0. So you have to make sure you look at your answers and that they work in the domain of that problem. So negative 3, well, in that one it works, but in both these two, right, log 2 of negative 3 would be undefined. So we have to cross out negative 3 as an answer, and we would say x equals 2 is the only solution to that problem. All right, so definitely some questions like that. Maybe you have to rewrite it as division, but using the properties and then having a quadratic to solve. Questions about that? All right, now look at this one. This is a hard question. And when I first did this, I did part of it. And then I looked at my book, and I feel that sometimes I'm failing you as a math teacher because I feel like I give you every type of example that you need in your homework, and you're going to get to college, and your professor's not going to do that, and you're not going to have those skills of knowing to go back and look in your book. And that's how I did this problem the first time. I found an example, I looked at it, I followed it, and then now I know how to do it. And so I just want to encourage you, one, use your notes when you're doing your homework, but also use your book, right? I don't do the examples out of the book for the reason of I want you to have different examples that you can go back and look at. So those are great resources to use as you're figuring out how to do problems. Because every year on a problem like this, when it's really hard and difficult, people say, how am I supposed to figure that out on my own? Well, you find an example, and that's why I give you an example. so that now you do have something to look at. But I bet you could at least give me the first step in this problem. What would be the first step in this problem? Yeah, let's get rid of the fraction, right? Let's make it look not so bad. Let's multiply by 2. So I get 2 to the x minus 2 to the negative x equals 6. And then this is kind of just ugly. And again, this is kind of the step that you need. You need an example to follow to at least get to the next step. So what we're going to do here is we're going to try to make this fit quadratic form. Do you remember doing U substitution for factoring in Algebra 2? Like if you had like x to the 4th plus 2x squared plus 2, that you could be like U equals x squared, and you could rewrite that, right? No? You could do it with like if you had x to the 8th plus x to the 4th plus 7, then your u would be x to the 4th, because then that makes that u squared plus u. We call that quadratic form, all right? We're going to take this idea and we're going to apply it to this problem. But before we can do that, we have to make it fit this. So what you're going to do every time, whether it's 2 to the x, or sometimes they give you a problem, all these types of problems, these numbers are going to be the same. Like it's going to be a 2 to the x and a 2 to the negative x, or a 7 to the x and a 7 to the negative x. What we're going to do is we're going to multiply everything by 2 to the x power. And that's kind of the, like I needed that help. I didn't know where to go in this problem. I needed to find an example to show me this. Because we can try other things. You can say, well, what if I add this over? We can't just ln both sides on this because of this subtraction. That's what makes it so different. Because we can't ln a subtraction and then break it apart. All right, so that's kind of what makes this different. So now let's think about our exponent rules. What would I get if I took 2 to the x times 2 to the x? What do we do with exponents when we multiply with the same base? What is x times x? Because we leave the base alone and we add the exponents. So I'm going to leave my base alone, and x plus x is 2x. What about this one? What happens when I have 2 to the x and 2 to the negative x? That would give me 2 to the what power? What's x plus negative x? 0, right? Like when we multiply exponents, we add exponents. Same base, x plus negative x is 0. And over here, you cannot take 2 to the x times 6 and get 12 to the x. So we just get 6 times 2 to the x, or 2 to the x times 6, like however you want to write it. But like you can't put those together, like you have to write that as 6 times 2 to the x. Why can't you put these together? It's 12 to the x? Yeah. Because it's just, think about order of operations, right? Exponents go first. So like think about if you plugged 1 in here for x, you would get 2 times 6 is 12. That works for if you say 12 to the first is 2, right? But that doesn't work once you start doing higher powers. If you did 2 squared, you get 4. 4 times 6 is 24. If you said 12 to the second is not 24, like it's just not equal, because order of operations say we do exponents first, and then we multiply. So you have to keep them separate.
Why isn't it like x squared? Oh, I guess it's because it's already, I don't know.
Because the a to the x times a to the y, right? We have to just think about our rules. We're talking about when we multiply exponents, we add them, right? Because they're already exponents. X times x is x squared, but these are exponents. So when you multiply with exponents, you add the exponents. So that's why you get 2x. I didn't. Again, isn't that the rule? Like when you multiply, like when it's x's, we know we don't change the base, right? When I take x times x, I don't change that base. I keep it as x, but I just add the exponent. It's the same thing with numbers. And again, it changes. If I took, let's think about real numbers here. if I took 2 squared times 2 to the 4th, what's that saying? That's saying there's 2 2's and there's 4 2's, so I add those and I get 6 2's. I don't get 4 to the 6, right? That's a whole different number. That's why. Like, so the rule is, like, we keep the base the same, we add the exponents. Okay. See, look, it's a good problem. It makes us review all of our exponent rules. Okay, so here's what I want to do. I'm going to move this over, and what's 2 to the 0? That's just 1, right? So I'm going to say 2 to the 2x. I'm going to subtract this whole thing, all right? So I'm just going to say minus 6 times 2 to the x minus 1 equals 0. Why did I do that? Because what if I had this problem? What if I had x squared minus 6x minus 1? Would you know how to solve that problem? Yeah, that's quadratic. We've been doing that forever. So this now fits quadratic form, which is why this is like so important of a step to do this problem, because you have to make it fit the form. What would my u be in this problem to make it fit u substitution? Do you know what u would be? Let's practice. What would u be in this problem? X squared. What would u be in this problem? X to the 4th? Because you want it to be able to fit that you would have u squared plus 2u plus 1. Or really then the shortcut is, how do you check that it works? You have to make sure that this exponent is half of this exponent. And if that's true, then your u is just always that middle value. So like this one, it was x squared, because then this would be u squared. This is x to the 4th, because if you square that, you get x to the 8th. So what would my u be in this? Not just x, because if I just put an x, then I'd have 2 to the u. That's what doesn't help me, right? So can this whole thing be my u? I'm going to make u 2 to the x. Because the 6 is just the coefficient. Watch me when I replace it, I promise. Okay. If u is 2 to the x, do you agree this middle term becomes minus 6u minus 1? And if you know u substitution, that first one better become u squared. And it does, because you can think about this as 2 to the x quantity squared. No. Yeah, that's right. Because that would be 2x. So that's just u squared. So that's where this comes from. I need to move this over. So this is just u squared minus 6u minus 1. We've done a ton of work already, and then very disappointingly, this is not factorable, right? So to solve this, you either need to do the quadratic formula or complete the square. It's really a great problem to complete the square with, since there's nothing in front of here and that's even. But I feel like you guys are always quadratic formula people, so I'll just do quadratic formula too. But notice it's not what x equals now, it's what u equals. But the quadratic formula hasn't changed. Yes. I was just showing why this is u squared, right? Like this is the same. I was just trying to show that this is just that. That u squared is 2 to the 2x, it's really just u squared. Because if that's u, then you square it. But it works every time. I think there's one in your homework that has 3 to the x's instead of 2 to the x's. But it's exactly the same. It's just a lot of work. Because now I do the quadratic formula. And I'm going to do negative b plus or minus. I got to find what x is, right? So like I still have a lot of work to do. I got to find what u is. then I gotta plug u back in, and I gotta find what x is. You can complete the square. No, you complete the square. I would complete the square if it was me, but I feel like grading your tests and quizzes, like, hardly anyone ever completes the square. So I'm trying to do what you guys do. But yes, clean the square, you could add 1 over half of 6 squared, add it to both sides. We should get the same answer. So I'm going to get 36 minus 4 times 1 times negative 1 all over 2 times 1. I'm just going to keep working this way. 36 plus 4 is 40. I could rewrite that as the square root of 4 and the square root of 10. Remember quadratic formula, simplify your radicals, and then you can divide by 2, so you would get 3 plus or minus radical 10, because the 2's would cancel out. 6 divided by 2 is 3. But that's not my answer, right? That's what u equals. I don't care about you, as a joke. But the goal is, I want to know what x is, right? U substitution is a way to help us, but we have to plug back in what was u. U was 2 to the x. So now I can say 2 to the x equals 3 plus the square root of 10, and 2 to the x equals 3 minus square root of 10. And now, after all that work, I've finally gotten to a point that I can solve this using what we did yesterday. Questions on getting up to this point? What would I do now to both sides to get that x out of the exponent? What did we do yesterday to solve this? ln both sides. So I'm going to say the ln of 2 to the x equals the ln of 3 plus the square root of 10. Bring that x out front and divide that over. So I'm going to say ln of 3 plus the square root of 10 all over ln of 2. That's my exact answer. And then I can plug that in my calculator. I'm going to extend page on your notes, right? So 3 times square root of 10? Where do you see 3 times?
There's not a plus sign. Very right.
Oh, this is a minus. Sorry. That's just my 2 answers, because it's plus and minus, right?
Okay.
Sorry, I'm not over there yet. That's why I was confused.
You're getting there, then what's up?
Yes. What issue do you have over here?
No, I
Did you?
curious if
Oh, yeah.
you only
Oh, well, what happens? Is 3 minus the square root of 10 a positive number or a negative number? You could type in your calculator. Is the square root of 10 bigger than 3 or smaller than 3? It's bigger, because the square root of 9 is 3. So this is going to be a negative number. So we could actually work it out and get an answer. But when you type in the ln of this in your calculator, can you take the ln of a negative number? No. Or another way to think about it, can 2 to the x ever equal a negative number? Which means if one of your roots is negative, we're not going to have to solve this because it can't, it's not in the domain, right? But if you worked it all out and then you typed it in your calculator because you didn't realize it was negative and that you couldn't do it, your calculator will tell you it's a domain error. But because this is negative, it's not in the domain. So if you recognize that, you can save yourself some work. If you ln both sides, you can't take the ln of a negative number. So this is really my only answer. Told you that was an exciting one. Good news is there's only one of those on your homework. That's good, right? So if I type this in my calculator, again, I think it's a good habit that you're practicing this. It starts a parenthesis for your square root, so that means you have to close 2 parentheses if you're typing this in all at once. and you would get an answer of about 2.623. And the other one would be a domain error, which means there's not an answer. Last year, or maybe the year before, Mr. Bain came in unexpectedly and observed me on this problem, and then he saw me in the hallway later, and he said, I don't even know what was happening in your class, but I'm never coming back. And I was like, it was kind of a rough one. That was a rough problem to observe. On your homework tonight, there's a question just like this, only it's powers of 3. Please use this example to help you and get there, and then I can answer questions if it doesn't work out. But try this, all right? Like, you got to use this to help you. The good news is that this makes the rest of the homework, the rest of the problems easy, right? If we wouldn't have done the last one, this would have seemed like a terrible problem. But now this doesn't seem so bad. This one doesn't have any crazy U substitution. Any suggestions how I could solve this equation? This is one of those logistic graphs, like the population graphs we did, where we like estimated and where we used a graphing calculator. But now that we can solve these, we can just solve it. Can I take this and multiply it over here? That sounds like a great idea. So I'm just going to multiply that over, right? Because I'm going to multiply both sides by it. 1 plus 95e to the negative 0.6x. Always make sure you, it always stinks when you miss a question because you type something wrong. Like I almost put 0.06. This is just kind of a couple steps more than the E problems you did yesterday. The goal is get E by itself so you can L in both sides. There's just a lot more numbers around. So we have options here, and there's really no right or wrong answer. It just depends on what you want to do. We want to get E by itself. So one option is we could not distribute the 150, and we could just divide the 150 over with the 400 right away. Or the other option is we could just distribute the 150 and then subtract and divide. We're going to get the same answer either way. It's just your choice. All right? So distribute, not distribute. Not distribute? Okay. I'm not going to distribute this. If you want to distribute, I promise we'll get the same answer. I didn't distribute on my paper here either, because I knew I wanted to get E by itself, so I just went ahead and divided that over here. Again, please be exact until the end, which means when you type this in your calculator, you're going to get a decimal. So either know how to type it in your calculator and get a fraction, or don't even reduce the fraction until the end. I don't care, right? Like, you're going to get a decimal at the end anyway. But you can reduce that really easily as a fraction. The zeros cross out. 40 and 15 are both divisible by 5, so I think that's just 8/3. I'm just trying to get E by itself, so we're just undoing everything. So what are we going to do? We're going to subtract 1, then what are we going to do? Divide by 95. 8/3 minus 1, 8/3 minus 3/3 is 5/3. If you don't have a lot of practice with using calculators and keeping things as fractions or knowing how to go from decimals to fractions on your calculator, please see me. I'll be happy to help you. When there's time left in class, ask me questions like that and I can help you. Because you want to make sure you're proficient using your calculator before the test. Because I do want exact answers if possible. Right, dividing by 95 here, doesn't look so nice. But you can do that on your calculator if you just do it in fraction form. Yeah, I think it will work. Or there's that fraction to decimal form. I didn't even do it on mine. I just left it like that. But that's right. Fraction to decimal, and then you can do this. 475 over 3, is that true? 95 times 5 is 475? Yeah. So that's the same as 475 over 3, or 158 and something, I think. Gosh, I keep messing up my decimal. 0.6x. I I just typed this in my calculator. 5/3 divided by, I used the fraction button the whole time, so I did 5 fraction bar 3, fraction bar 95, and it gave me the mixed number. And then I did, on my calculator's second fraction button, and it gives you an improper fraction, so I didn't even have to think about it. But really, you're just taking 95 times 5, which gives you 475, and then 3 on the bottom. You didn't get that? I don't know what you did. What did you get? Did I do it wrong? I got that. Am I wrong? Maybe I did it wrong. Divided by 95. Oh, my fraction button failed. 157, excuse me? Yeah, that's right. Alright, thanks. Failure on my calculator. That's what I mean. Here's what I did on my paper, just so you know. I just type lots of parentheses on my calculator. So when I ln both sides, like, I didn't even simplify that. Like, I wrote ln of 5/3 divided by 95, and I just typed it all in instead of simplifying it, just to keep it exact. But 157 is the right answer. Sorry about that. I have too many fraction buttons on my calculator. It did not like it. I think it took 3/95 times 5. I don't even know what happened.
I didn't use all the fractions. I went
Calculated
5
error.
fractions, but then split it into 5.
And then split from fraction to decimal?
Yeah.
That's the way to go. I think we should get ln of 157 equals ln of e to the negative 0.6 x, because ln of e is how that's going to cancel out. So ln of 157 to get x by itself, I'm just going to go ahead and say dividing by 0.6. Right, that's not a pretty exact answer, but that's an exact answer. ln of 157 divided by negative 0.6, I got 6.738. Did anybody else get that? And again, we're going to do some story problems with this eventually, but that's like saying an initial population was 400,000, and it's decreasing at such and such rate. When will the population be 150,000? This would be an answer of like 6.7 years. And so that's how you can do that without a graphing calculator, without guessing and checking, that we can just do the algebra and solve that equation. Okay, I got one more question for you about Newton's law of cooling. You ever learn about Newton's law of cooling in the sales class? It's a whole lot of words. This is the whole reason I printed your notes up today. Look for this right here. It's in your book. There's a whole little box about it if you want to read more about it. But Newton's law of cooling says an object that has been heated will cool to the temperature of the medium in which it's placed, such as the surrounding air or water. If you bake a cake and you get it at 350 degrees, and then you take it out of that oven that's 350 degrees, and you put it in a room that's 70 degrees, then there's a formula to figure out in how many minutes will it be such and such temperature. Same thing with coffee. You can say the coffee is this much and whatever. So it's kind of cool. So there's just an ugly equation here. The temperature T of the object at time T can be modeled by this equation for an appropriate value of K, where T sub M is the temperature of the surroundings, the medium. T sub 0 is the initial temperature of the object. And T is the time, right? The little t is the time. K is some constant value that we have to find. All right, so knowing that equation, you don't have to memorize it, then you can solve the next problem here, and I'll do a double page here so we can keep this. I don't have this equation memorized. But it says a cup of coffee has cooled from 92 degrees Celsius to 50 degrees Celsius after 12 minutes in a room at 22 degrees Celsius. How long will it take to cool to 30 degrees Celsius? So just like what did we do? Like direct variation, inverse variation, like you have to solve for that constant first. The first thing you have to do in this problem is you have to solve for K. It's probably time to, isn't it? I'm about to lose you in like 1 minute. I'm not sure. So the first thing you have to do is solve for K. So I'll at least do that part, and I'm going to hold you hostage here. It cooled from 92 degrees. What does 92 degrees represent in this problem? The initial temperature, all right? And it cooled down to 50 degrees. What's that? Which one's the surrounding value in this one? 22 is the surrounding. This is the new temperature, which is what this is over here, right? So I think we would say 50 equals surrounding was 22 plus the original was 92 minus 22 to the e to the negative, how many minutes did it take? 12 minutes, so I'm going to say negative 12k. They give you everything but what k is. So step 1, and where I'm going to leave you because the bell's going to ring, is step 1, you have to solve for k. And you're going to get k equals some ugly decimal. I'm going to write ugly decimal. And then step 2, use that k value to find how long it will take to get to 30 degrees, which means we're trying to find how long, so the time it takes to get this to equal 30. Probably in 6th hour, I'll be able to finish this because they don't have fry time. So I'll put that on the Google Classroom page if you want to check it out. Otherwise, we can talk about it tomorrow. But there's an example in your book about this. You have your homework on your paper. And I think I'll see you tomorrow before we go to bed.
Taylor, Adrian
Good night.
Bill,